Hi, Assalamualaikum. My name is NURSYAFIQAH binti Abdul Wahab, menstruate number 055669. So a little bit about data compression. Data compression is a process of reduction in the number of bits that is needed to represent data compactly so that the capacity of the storage is lesser and of course to decrease the cost for storage hardware and network bandwidth. Example of compression software that I believe everyone has ever used it, such as Zip, gzip, WinZip, and even there is online website that offers to compress files and folders and ready for the use of compression purposes. For our project, we will introduce 4 techniques which will be covered by my team later. But for my part, I will explain a little bit about arithmetic coding. Arithmetic coding is set almost similar to the Huffman coding, which they both converts a whole file into a smaller number into a single decimal number as a sequence symbol. The only difference is arithmetic coding allows fractional bits to be used. And figure here is the subdivision of the current interval based the probability of the input symbol A that occurs next. This is to prove that arithmetic coding allows each iteration to process one of these input symbols, and on each of the iteration, the initial is divided into sub-intervals according to the probability distribution. For the next iteration, the sub-interval that corresponds to the input symbol is chosen. Now, let me explain about this pseudocode of the encoding strings on how additional symbols may be added to an encoded string by restricting the string's range bounds. Encoding strings starts by assigning each symbol its own unique probability range. It is possible to encode a single symbol by its range. By this approach, a string can be encoded as a series of probability range, but it does not compress anything. Instead, additional symbols may be encoded by restricting the current probability range by the range of the new symbol being encoded. Any value between the computed lower and upper probability bounds now encodes the input string. Next, I want to share the detailed analysis that I have made on arithmetic coding. First of all, arithmetic coding has been offered as an upgrade to existing compression algorithms and compression-related activities due to its near-optimal compression performance. Because the Zipf-Lempel coding output values are not uniformly distributed, some academics have suggested utilizing arithmetic coding to further compress the output. Although compression has been improved, the technique has been slowed and its complexity has increased. And another significant benefit of arithmetic coding is its efficiency. In the sense of encoding with the shortest average code length, arithmetic coding is optimal in theory and nearly so in practice. Because Huffman coding is also near to the optimal of the circumstance, the optimality often less relevant than it appears. However, when the probability of the single symbol is close to 1, arithmetic coding performs significantly better than other approaches. Highly balanced probabilities are common in bilevel, which is black and white image coding, and they can also occur when a multi-symbol alphabet is decomposed into a series of binary options.